Friday Bytes by Helixz.
Good afternoon, everyone. I'm Janith. First of all, thank you for giving me this opportunity. Today, I want to talk about something that really changed the way I think about infrastructure. The title of this my session is Stop Clicking, Start Coding, and Introduction to Terraform. As developers, as developers, we love writing code. But when it comes to infrastructure, servers, databases, networking, many of us still rely on the clicking through cloud dashboards and also cloud consoles. Today, I want to show why that approach is risky and how we can manage our infrastructure the same way we manage our application code. So let's start with the simple question. How many of us have created a server by clicking to a AWS or Azure console? It feels easy, but this is what we call as ClickOps. And honestly, it was a trap. Every click is a potential mistake. Maybe you forgot to enable version. Maybe you select the wrong region. Maybe you missed one small checkbox. And the worst part is there is no proper version history. You don't really know who changed what, and you cannot easily recreate the exact same setup again. So when development and staging and also production environments are slightly different. So that's when we hear it works on my machine, but not in server. So manual configuration create inconsistency, and inconsistency create bugs. So how do we fix this? The answer is infrastructure as code. Instead of clicking, we write configuration files, just like we write backend code or front-end code. There are three powerful advantages here. First one is we can manage through code. Our infrastructure lives inside the code files, inside our repository, like our backend source code or front-end codes. So second one is version control. Since it is a code, we can use Git. So we can track changes, review pull requests, and review rollback anytime, any change. So third one is reproducible. We can create identical environments again and again. Development, staging, production, all using the same configuration. No more guessworks. So let me introduce Terraform. Terraform is an open source tool created by Helixz. Its main purpose is simple purpose, provision and manage infrastructure using code. It has very simple main purpose, that was provision and manage infrastructure using code. There are three important things to understand about Terraform. First one is Helixz configuration language. It is very readable. Even if you are not a DevOps expert, you can easily understand it quickly. Second one is state management. This is a Terraform's brain. It remembers what infrastructure it created. So it knows what to change and what to keep. So third one, provider ecosystem. Terraform works with AWS, Azure, GCP, and hundreds of other services. That means one tool, many clouds. So now let's talk about how Terraform actually works. It follows a very simple three-step workflow. Write, plan, and apply. First we write. we define our infrastructure in TF files using HCA. When we are using Terraform, we created files with extension .tf. So second part is we plan. We run the Terraform plan command. This is like a preview. It shows us exactly what Terraform will add, change, or delete before it actually touch our cloud. Third part is final part, we apply. Once we are happy with the plan, we run Terraform apply. Terraform then talk to our cloud provider and build everything for us automatically. So let's talk about the most important of Terraform, state management. Think of the state file as a Terraform memory. It stores everything about our real resources, like their IDs, current settings. This allows Terraform to detect configuration drift, which means it can see if someone manually changed something in the cloud that is not our code. For best practices, we should always store this state file remotely, like in S3 bucket, so our whole team can work together. And finally, most important thing is never upload the state file to Git because it contains sensitive information. So we always add it to our gitignore file, like we add our env files into gitignore files. So one of the most powerful features of Terraform is modules. Modules allows us to reuse infrastructure code. Instead of rewriting same configuration again and again, we create a reusable block. We follow a principle called DRY, which stands for don't repeat yourself. Using modules, it gives us three main benefits. First one is consistency. We use the same module to ensure that our dev, staging, and production environments are always identical. Second part is maintainability. If there is a bug or an update, we only need to fix it in one central module. That change then flows to every place where that module is used. So third one is fast development. We don't have to write everything from scratch every time. We can just assemble our infrastructure using pre-built tested modules like Lego blocks. Think if there is a bug, fix it in one place, all environments get updated automatically. It's like a reusable components in front-end development. Next part is security. Security is a top priority when we manage infrastructure. When we use in Terraform, we must follow three golden rules to keep our data safe. First one is never hardcode secret. We should never put password, API keys, or database credentials directly into our code files. If we do, anything with access to our Git repo, anyone who have access to our Git repo can see them. So never hardcode secrets. Second one is exclude state from version control. As I mentioned before, the state file contains sensitive data. We must always add Terraform state file to our gitignore file to ensure that it never upload to GitHub or GitLab. Third one is leverage secret managers. Instead of storing secrets in code, we should use professional tools like AWS Secret Manager or HashiCorp wallet. Terraform can safely pull these secrets from it when it need them without ever exposing them in our files. So after all that theory, let's look at some real code. This is how we define an AWS S3 bucket in Terraform. As you can see, the syntax is very clear. First, we define the bucket itself and add tags like environment and project. Below that, we have another block to enable version. The great thing is here, Terraform automatically understands dependencies. It knows it must create the bucket first, and then it enables the version. Think about it. If we are writing these few lines, is much faster and safe than clicking through 10 different screens in the AWS console. So why should we actually use Terraform? Here are 5 key benefits. First one is fast deployments. We can reduce our provisioning time from hours to just minutes. If tasks took half a day to configure our AWS registries, SQS, DLQs using manual configuration, but using Terraform, we can done it in one command. Second part is zero drift. It eliminates the gap between our code and our actual cloud resources. Terraform ensures that what is in the code is exactly what is in the cloud. Third one is easy scalability. We can deploy hundreds of identical environments like dev, staging, and production using the same exact script. Fourth one is immutable infrastructure. Instead of trying to fix a broken server, we just destroy it and rebuild a fresh, perfect one from our code. The last one is centralized GitOps. Finally, our infrastructure live in Git. We have a complete history of our changes, making it easy to track and audit everything we do it fast. Finally, let's talk about the real world impact. How does Terraform help our team every day? It ensures we consistent environments from start to finish. First one is development environment. Developers can spin up an identical environments with just one command. This solves the famous error, works on my machine, not in the server issue, because everyone used the same code. Second one is staging environment. We can test our changes against infrastructure that looks exactly like production. This helps us catch configuration bugs early before they reach our users. Third one is production environment. We can deploy to production with our project 100% confidence because the code was already tested in staging. We know it will behave exactly the same way in the live environment. In short, Terraform removes the fear of development and make our releases much safer and much faster. So finally, if you want to try Terraform today, first install Terraform, learn basics of HCL, start small. Just create one S3 bucket. Don't try to automate everything on one day. Start small, grow gradually. So finally, Terraform is a game changer for how we manage infrastructure at Helixz Solutions. It makes our work faster, safer, and much more professional. Thank you. Thank you very much for your time. Now I would love to answer any question you might have about Terraform or its configuration. That's it.